Okay, now let's just find the antiderivative of these functions. We have the function to be 1 over 9 plus x squared over the x variable. Okay, great. Now look at this. The function is just a rational function, and it looks as if we can resolve this to its partial fraction since it has a quadratic term at the bottom. But this right here, the denominator, which is just a quadratic term, does not have real factors. So we will not go through that direction, right, of saying let's resolve it in partial fraction. We are going to have complex factors, and I don't want to go there, right? Okay, so what can we really do? Well, in my previous video, I gave us different forms of integrals, okay, how they can appear, and the different things that we can actually substitute, or different trigonometric functions we can actually substitute. So I made a statement that if we have something of this form, let's say to find the antiderivative of let's say x squared plus a squared, where a is just a constant, right, over the x variable, then the substitution should be that x should become a tangent theta. Okay, great. So let's just do it over here. So I will start off by saying let x be equal to a tan theta. Now notice this is 9. Okay, in the next step I can change this 9 to 3 squared. Alright, so let's say that x should be 3 tan theta. Alright, great. And then if that is the case, that means that dx, we differentiate that over the theta variable, or with respect to the theta variable, dx will become 3 times, well, the derivative of tangent theta is secant squared of theta. Alright, and then we just put down the d theta over here. Okay, great. Now take note that since x is 3 tan theta, alright, that means we can make theta subject of formula from here. So we're going to see that theta will become, divide both sides by 3, okay, and take the tangent inverse of both sides. That will become tangent inverse of x over 3. If we try to make theta the subject of formula from there. Okay, great. And now let's see what the integral become. We're now going to have this to be the integral of 1 over, well, you notice that this is 3 squared, maybe it's 9, let's just put it at 3 squared, alright, and then we add it with, well, x squared. What is x? X is 3 tan theta, so you are going to square 3 tan theta. That means 3 squared times the tangent square of theta, right? And then dx is 3 secant squared theta, 3 secant squared of theta d theta. Alright, great. And now let's see what we got. In the denominator, we can factor out 3 squared, alright? And we are going to have 1 over 3 squared, which is just 9. And I can push it out of the integral sign, okay? 3 squared, factor it out. And we're going to be left with 1 over, okay? We're going to be left with, now in the numerator, we can put this to be 3 secant squared of theta, d theta. And then we divide that by 1 plus tangent squared of theta. Okay, great. Now you should take note that from trigonometric identities, we have secant squared of theta to be 1 plus the tangent squared of theta. Alright, so that means the whole of this denominator, 1 plus tangent squared of theta, is the same thing as secant squared of theta. So that means we can equate these two. We put these 3 out front, will be 3 over 9, which is just 1 over 3. The integral of secant squared, right? That will become 1 d theta. So that means we are just integrating 1 over the theta variable, where the secant squared will cancel out with this term, which is exactly secant squared as well. So if you are taking the integral or the antiderivative of 1 over the theta variable, this is going to give us 1/3 of theta. And what is theta from this our substitution? Well, we can see that theta is just tangent inverse of 1 over 3. So this will become 1/3 of tan inverse, there's no point for the bracket, 1/3 of tangent inverse of x over 3. Alright, and since we are done, we can add an arbitrary constant, and this right here is the antiderivative of the function given over there. And in general, I would say that if we have to find the antiderivative of, let's say, a squared plus x squared over the x variable, where this a is just a real number and it is not equal to 0, okay, then the antiderivative will become 1 over a times the tangent inverse, or if you like, you can call it arctan of x over a, and then an arbitrary constant. This right here is the general case, but that's what you get. All right, thanks for watching. Please subscribe to my channel.